Okay, hello, scholars. So let's get this work going. We know we have our unit tests tomorrow, so we want to just make sure we do any extra studying we can to make sure we are prepared and on point. So first, of course, we want to read because it's fundamental. Select all means that there will be more than one answer choice. So you should put that more than one answer. Um, and it says represent a speed of 60 units, right? Speed of 60 units. The reason why I put units because as you know, in all of this information, they're talking about miles per hour, meters per minute, meters per minute. And so like the unit can be different, but as long as it's 60 of the unit, then you know it is correct. So there are three different options. So we need three different tables to help represent this word. And so let's go. So it says Mr. Ray drove 200 miles in 4 hours. Clearly, we're talking about miles and we're talking about hours. Speed is distance over time or distance divided by time. Okay, we've been working on this in class tons. So like hopefully you can remember speed is distance over time. So what do we know about this problem? 240 miles. So under miles, I put 240 and it says 4 hours, right? Now, in order for us to determine the speed, we need to do it in 1 hour. So to get from 4 to 1, we have to divide by 4. And then what we do on one side, we do on the other, which is divide 240 by 4 also. Another thing we can do is multiply by 1/4 because to divide by 4 is also to multiply by 1/4. So we have 240 divided by 4, and thus that is 60, which means the speed is 60 miles per hour. If you just put 60, that is incorrect because this speed is given in miles per hour. So since we're looking for a speed of 60 units, we know that A is correct. Now let's look at B. Colin rode his bike 24 meters in 4 minutes. So we're representing meters and we're representing minutes. We know it's 24 meters and we know it's 4 minutes. And with speed, the time has to be in 1 unit, right? So meters are not time, minutes are time. So we want to put 1 under minutes, and we have to divide that by 4 as well. And 24 divided by 4 is 6, which means this is 6 meters per minute. This is incorrect because we're looking for a speed of 60 units. Let's look at the last one. Amaya ran 24 meters and 4/10 minutes. So we're comparing meters to minutes. Now, this is a little tough because it says 0.4. Now, we could also look at it as if it's 4/10 because we know 0.4 is 4/10 because the 4 in 0.4 ends in the tenths place. So it's 4/10. Where we need to figure out 1 for the time. And so we're trying to figure out like how far in 1 minute or 1.0 or 10 over 10, right? So the reason why I put this on the third column instead of the second column, because there's no multiplicative relationship between 4/10 and 1 whole using a whole number. But there's a friendly factor we can use that can help us get from 4/10 to the friendly factor, and thus the friendly factor to what we're finding. Well, one is always, a unit rate is really always pretty cool, but 0.1 wouldn't really help us as best as 0.2 could, or 2/10, right? So to get from 4/10 to 2/10 is to divide by 2. What we do on one side, we do on the other, and that gives us 12. And to get from 2/10 to 10/10, or 0.2 to 1 is times 5, and 12 times 5 is 60. And thus you have 60 meters per minute. And that would make C correct because we're looking for 60 units, a speed of 60 units. Let's go to the next one. Miss Cook drove to the shore this past weekend. On her way there, she stopped at a gas station. Okay, so let me just draw this out to you. So she's driving. She stops for gas right here. And after traveling 60 miles. So from here all the way to here is 60 miles. And that represents 60% of her trip. And then she needs to keep going, right? How many miles does Miss Cook need to travel? So we need to figure out what else we need. Well, what do we know? We know 60 miles equals 60%. We also know that we need to find 100% of the total trip miles. We're going to look at this in two different representations. First, if we're looking at 60%, we know that 60% can be a friendly factor of 60% is 20. So we know that if we created like a tape diagram, we could split it into 5 sections, right? 20%, 40, 60, 80, 100. And we know, and these are percentages, we know 60% is 60 miles. To get from 60% to 20%, we divide by 3. Thus, we need to divide 60 by 3, and that gives us 20. What that tells us is that every 20% is 20 miles. So 40% is 40 miles, 60%, 60 miles, 80%, 80 miles, and 100%, which is the total trip time, is 100 miles. Another way to look at this is through an equivalent ratio. We know that 60 miles is equivalent to 60%. And every percentage is over 100%. We don't know what the 100% is equivalent to, right? So what we can do is we can cross multiply 60 times 100, which is 6,000, divided by 60x, right? All of those cancel out. 6 divides into 6 one time, thus it will be 100. We also know that 6,000 divided by 60 is 100. So we know that is 100 miles. Now let's also look at it like as a table. In this problem, we're comparing miles to percentages. We know 60 miles is 60% because she stopped at gas. We're trying to figure out how many miles is 100%, but we needed to use a friendly factor because 60, there's no whole number multiplicative relationship between 60 and 100. There's a decimal, but like a whole and a decimal, but not a whole number. Thus, 60 goes into 20 divided by 3. What we do on one side, we do on the other. And then 20 times 5, and then you multiply times 5. And so to answer our question here, we know it is 100 miles. For Miss Cook, to go to shore. Okay. In this problem, it says each row has a different speed. We already know we're talking about speed, so we just want to write speed is distance over time, or distance divided by time. What is the speed for each row? So here we have a row. Distance is in miles, time is in hours. So here we would have to do 45 over 0.5, or 45 divided by 0.5. And that is going to be 90. However, we need to say what that is. We're dealing with miles per hour, so it's 90 miles per hour. The next one, 70 over 1, or 70 divided by 1, which is 70 miles per hour. The last one is 115 over 1.5, or 115 divided by 1.5. Then you go ahead and divide that and determine what the answer is in miles per hour. Let's go to the next one. There are 120 M&Ms in a sharing size bag. Okay, so that tells us that in a bag there are 120, and that represents the total. And we know total is 100%. 40 of the M&Ms are green. So 40 are green. 30 of the M&Ms are yellow. 30 yellow. Do you see what I'm doing? As I'm reading, I'm writing down information, right? That helps us not spend so much time, right? I see a lot of numbers and I want to get those numbers down so I can like make sense of what the numbers are. So that'll help me get through this problem a lot faster. And 20 are blue, and then the rest are brown. What percentage of the M&Ms are green? Well, I could create a table and I'm comparing like M&M to percentages. I know that 120 M&Ms represents 100%. The question asks, what percentage of the M&Ms are green if the total is 120? We know that there are 40 green M&Ms. And here I put 40 directly under 120. It's because there's a multiplicative relationship between 40 and 120. 4 times 3 is 12, thus 40 times 3 is 120. Okay? So to get from 120 to 40, I have to divide by 3 or multiply by 1/3. And thus what I do on one side, I have to do on the other, and 100 divided by 3 is, let's see. And this is why division is very important. 3 goes into 10 3 times. 3 goes, that's 9. 3 goes into 10 3 times. It's 9. Remainder 1, so it's 33 and 1/3. 33 and 1/3%. What percentage of the M&Ms are yellow? Well, we know there are 30 yellow. There's no multiplicative relationship between 40 and 30, but there is a relationship between 120 and 30, and that is to divide by 4, and 100 divided by 4 is 25. So my answer, where it says what percentage of the M&Ms are green, it's 33 and 1/3%, and 25% are yellow. Make sure you pause, rewind, do whatever you need to do to understand what's happening. On YouTube, there is a way to slow it down if you feel like I'm speaking too fast. want to get this to you. So let's go ahead and turn the page. Jared and Messiah are at two different ends of a 36-mile park trail. So Messiah, Jared. If they are biking towards each other, do you see how I'm able to draw a model of literally what I'm reading? Then how long did it take them to meet? Messiah is biking at 3.5 miles per hour. So in 1 hour, he's biking 3.5 miles. And Jared is biking 4.5 miles per hour. So in 1 hour, okay, we're trying to see like how long does it take them to connect to each other. So here's what we know. We know that Jared is biking 4.5 miles per hour. Messiah is biking 3.5 miles per hour. They are sharing a total distance and they have to meet up at a certain time. Thus, we know that in 1 hour, we need to combine Jared and Messiah, which would be 4.5, which would be 8 miles per hour. So basically, although they're traveling at two different distances, in 1 hour, they would have traveled 8 miles, which would make them even closer to each other. We also know that the distance travel is 36 miles. So that's the total distance. So it looks like we're comparing distance and time. And so let's create a model to represent that. Distance and time. We know that in 8, well, the distance is in miles and the time is in hours. Do you see how labels really help you organize your thinking? So in 8 miles, they both traveled. I mean, in 1 hour, they both traveled 8 miles. What we don't know is how long it's going to take them both to come together. Um, and the total distance that they need to travel is 36. As you can see here, I put a space because there's no multiplicative relationship between 8 and 36, meaning like 8 times 4 is 32. However, 8 times a whole number with a decimal will be 36. There's thus we need to find like a friendly factor. So you want to ask yourself like what number can go into both 8 and 36? I know one can go into it, right? It's pretty simple. They're both even numbers, and if they're even numbers, two can automatically go into it. But I think four can also go into it. Yep, four goes into 8 2 times. Four goes into 36 9 times. And that's like the greatest number that can go into both of them. So I want to use that. This is known as the greatest common factor, and we'll be exploring that later. To get from 8 to 4, we multiply by 1/2, and 1 times 1/2 is 1/2, or 0.5. So now we got to figure out how to get from 4 to 36, and as we said, times 9, and 1/2 times 9 is 4.5, which means they will meet in 4.5 hours. Now, how do I know that? I know that because together they travel 8 miles per hour, and to get from 8 to 36, multiply 8 by 4.5, Okay, go to the next one. Remember, slow it down, pause it, rewind it, whatever floats your boat, do it. 20 people share 5 pizzas. What is the unit rate per pizza? So basically what that is asking is like, if 20 people share 5 pizzas, how many people is going to share one pizza? Now, how do we understand that, right? So we have people and we have pizza. We know that we always write what we know first. Our given rate, 20 people share 5 pizzas. Trying to figure out the unit rate per one pizza. So how much for one pizza? To get from 5 to 1, you divide by 5. 20 divided by 5 is 4. Now, what is that saying? That is saying that 4 people share one pizza. This says, what is the unit rate per person? Which means how much how much pizza for one person, right? So you want to put a 1 under the person. And what do we know? We know to get from 4 to 1, we divide by 4 or multiply by 1/4. And to get from 5, if we multiply 1 times 1/4, we have 1/4. So that means each person shares, each person eats 1/4 of a pizza. How many pizzas are used with 30 people? Hmm. Now, if we know one person uses 1/4 of a pizza and 20 people uses 5 pizzas, clearly 30 people are going to need more than 5 pizzas. So we want to put 30 here. And we can get from 1 to 30 by multiplying times 30. And so we just multiply 1/4 times 30, which is 30/4. And that's like 30 divided by 4. And 7 goes into 30 28 times. And the reminder that choice simplify to get it all 30 back. 7.5 pizzas for 30 people. We're here. This is the last one. Which unit of measurement is heavier, 20 pounds or 12 kilograms? We know that 1 kilogram is 2.2 pounds. Now, we have to explain this in a complete sentence, but before we do that, we have to create some type of representation to explain what's going on. We know we're talking about kilograms and we're talking about pounds. We know we always go to our conversion first because through our conversion, it can really help us be able to like determine the difference in weight between 2 different items. So we know that 1 kilogram is equivalent to 2.2 pounds. We're trying to figure out what is heavier, 20 pounds or 12 kilograms. We know the information to both of these, but one of these show a better multiplicative relationship. I know that to get to 12 kilograms, I just multiply by 12. So I'm going to use whatever I have the unit rate of. If I have the unit rate of kilograms, then I know I can compare it to how many kilograms is given to me. All right. So 2.2 times 12 is 22 tenths. times 12. 2 times 2 is 4. 4, 2, 2, 4, 6, 2, but it's a 10th. So that's 26.4. So now we know 12 kilograms is equivalent to 26.4 pounds. But we were asked what's heavier, 20 pounds or 12 kilograms. My answer would be 12 kilograms are heavier because 12 kilograms is equivalent to 26.4 pounds, and 26.4 pounds is heavier than 20 pounds. Okay. That's all I have. Don't forget to pause, write down all these notes because you'll need them to solve these problems, right? These problems will be able to greatly help you understand these problems. So taking all the notes will really help you be successful. And then I promise, you take this test tomorrow, you're gonna feel like a champ because not only did you watch the video, understand what's happening in the video, you did the work, and you tried your best, and you studied. All right. Take care. Bye-bye.